Okay, hi again everyone. Professor Sebastian, back to our statistics class notes. We're on page 69. And we're on this section talking about conditional probabilities. And I want to talk about independent events on this page. So variables or events that are not associated are independent. So how do we tell if two events are independent? Just by thinking about the events. The way we can think about it is if knowledge one happened tells us nothing about whether or not the other has happened, then the events are independent. Okay? So in symbols, if A and B are independent events, what we have then is the probability of A, given that we know B occurred, is still just the probability of A. It doesn't matter that we know B occurred. Okay, so that means that we have independent events. So let's try to simplify that with an example. Suppose a card is drawn from the standard deck of playing cards, and we're going to let C be the event a card is a club, and B be the event a card is black. We want to know if these events are independent. So what we need to determine is if the probability of a card being a club, C, given that we know it's black, is the same as just the probability of a card being a club. And also the other way around. If the probability of a card being black, given that we know it's a club, is equal to just the probability of it being black. So thinking about that, what's the probability of a card being a club given that we know it's black? So given that we know the card is black, we know that it's either a club or a spade. So that means there's a 1 out of 2 probability that the card is a club given that we know it's black. However, the probability of any card just being a club is 1 out of 4 because there are 4 suits, right? There's clubs and spades, but there's also hearts and diamonds. So those probabilities are not equal, and we could just stop there. If that was equal, then we would definitely have to figure out the next one, but I'm just figuring out the next one just to show you how to think about it. So now what's the probability of a card being black given that we know that the card is a club? Well, that's 1, because if the card is a club, it's definitely black. So given we know it's a club, we can say the probability of being black is 1. However, what's the probability of any card just being black? And that's 1 out of 2 because 2 of the suits are black and 2 of the suits are red. So 2 out of 4 is black, which is 1 out of 2. They're not equal either. So that means a card being a club and the card being black are not independent. And if they're not independent, we say they are dependent events. So if we return to our survey data, let's answer the following questions. We want to know if the events the person selected has a high school only education and the person selected is low income are independent. We want to know if those are independent events or are they associated, right? If they're independent, they're not associated. There's no relationship. If they are dependent, then there is some relationship here. So what we need to do is we need to determine the following. If the probability of being high school educated, given that your low income person, is the same as just being the probability of a high school educated person, and the other way around. The probability of being a low income person, given that we know you're high school educated only, is the same as the probability of being a low income person. So if I look at my sample, the probability of having a high school education, given that we know that they're a low income person. So that means we focus in on the low income group only. And high school educated in there is 58. So 58 out of 164, that's a 0.357 probability. However, the probability of being a high school educated person is this group, which is 110 out of the total 406. So that's a 0.7271. So that's a lower probability. So there seems to be some relationship between just having a high school education and whether you're in the low income group or not. However, we could stop there because these are not equal, but I'm just wanting you to understand how to do both of them in reverse order. Once they're not equal, once one of these is not equal, you could stop. But I just want you to see how to think about doing both of these. So the probability of being a low-income person, given that you only have a high school education, that's 58 out of 110 because we're focusing in on the high school educated group only. The low income in that group is 58. So 58 out of the 110. That's 0.527 probability. And the probability of being just a low-income person is all the low-income people, which is 164 out of 406. So that's a 0.404 probability. Again, those are not equal. we could have just stopped on the first one, but since the probability of high school education only, given that we know you're in the low income group, is not equal to just the probability of having a high school education only, and the other way around too, probability that a low income person, given that we know that they only have a high school education, is not equal to the probability of just being a low income person, the events are dependent. They're not independent. That means there is some association between these events.